So this is a mean value theorem problem, and we have two conditions that we need to meet. Go ahead, unmute yourself, Alondra, Isaiah, Jessica, Yerme. Unmute yourself. What are our two conditions? First, F should be
continuous
on the close. Let's just write that. And it should be
differentiable
on the open interval. So remember, closed, differentiable, open. So remember the C, do. You need to memorize that, okay? But we're not going to go into all that right now. But think about it. We have a sine squared and a cosine squared graph. I'm letting you know that sine looks like this. Can you see me? I don't know if you can see me.
Yeah.
See me? Sine looks like this.
Okay.
It's curvy, it's continuous, there's no sharp corners, there's no breaks. Same with cosine. So if I have a sine, cosine, if I have trigonometry that's similar to a polynomial, it is continuous and differentiable. Okay. Will be continuous and differential, will be smooth. So we know the conditions are met. Let's answer the question, find C. We have a simple equation to start with. M sec equals
M tan.
M tan. Okay, M sec means the average rate of change. What's the formula for M sec? What should we do?
F of B minus F of A over B minus A.
Okay, but a little more specific, what should we actually write immediately? F of
Pi over 4.
pi over 2. We start with the
Oh,
second
pi over
one, right?
2, my bad. Yeah, minus F of pi over 4.
Over.
Over pi 2 minus pi 4.
Perfect. Let's do sidebar. Let's figure out what F of pi over 2 is first. We want to figure out our left-hand side. So F of pi over 2, I'm just plugging it in. Is that sine of pi over 2 squared minus cosine pi over 2 squared? Okay, let's start. What's sine of pi over 2? Is this the x value or the y value? Sine.
1.
The y value, and at pi over 2, it's 1. 1 squared, 1. Let's do cosine. Cosine is the x or the y?
X.
X. And at this point, the x is 0 squared. So our numerator is just 1. So watch, I'm showing you best practice. Keep your left-hand side and your right-hand side clean, and use a sidebar for any additional work that you need to. And on the bottom, pi over 2 minus pi over 4. Let's multiply this top and bottom by 2. So I have 2 pi over 4 minus pi over 4 gives me?
Pi over 4.
And from our first week, how do we divide fractions?
Reciprocal.
Guys, stay unmuted. Yeah, we multiply by the reciprocal. So times 4 over pi. So our left-hand side is 4 over pi. Let's do the right-hand side. M tan, what are we looking for? What's it mean? Derivative. So we're going to write f prime of x. Next step, let's take the derivative. So let's start with sine squared. So look, there's a power. So I'm going to use the power rule followed by the chain rule. So 2 comes to the front. Yeah.
I'm confused. We didn't find f pi over 4, did we?
No, we didn't. You're right. We did not find f pi over 4. So I only did f of pi over 2. You're right. Let's find f of pi over 4. Thank you. Okay, let's do it in our brains. Pi over 4 is here. What's the sine value, the y over r, for 45 degrees?
1 pi over 2.
So y over r would be 1 over radical 2. And I'm going to square that. Minus, isn't the sine and cosine here the same for a 45? X over r is also 1 over radical 2. We're going to square that. Okay, so that cancels. It gives me 0. And I just happen to have the same work. But thank you for catching that, Kaylee. So it was really 1 minus 0 on top. Okay, let's continue on the right side. we're taking the derivative of sine squared x. So we haven't done this in a while. I'm going to write it down here. F equals sine squared x minus cosine squared x. But I want you to remember, this is really sine of x whole squared. So we're using the power rule first. Bring it to the front. What are we writing? 2. I am going to make a mistake. Do you see the error? Naya, do you see the
Doesn't
error?
sine stay? Doesn't sine stay instead of cosine? We're not taking out the derivative of it.
Thanks, Bridget. Yeah, the inside guys should stay the same. The chain rule says take the derivative outside. The power is now 1. And then we multiply by the derivative of the inside. You do the second half, negative cosine x whole squared. Take the derivative. Michael? Michael Reed?
Yeah.
Took the derivative of the first part. Tell me the derivative of the second part.
It'll be a -2 parentheses the cosine x, then times negative sine x.
Beautiful. Times derivative of the inside. So that gives me, won't that give me a positive plus the negative and the negative? So I
Yeah.
have 2 sine x cosine x plus 2, this is the same thing, sine x cosine x. What does that leave me with? I'm going to rewrite it. Guys, look, these are like terms. Sine x cosine x is the same as cosine x sine x. So what do I get? With like terms, you add the numbers in front. So what do I get?
4
4 sine x cosine
sine
x.
x cosine.
With like terms, you just add the numbers in front. So check it out.
So it wouldn't be squared, miss. It would just be adding the first numbers.
Correct, because we're not multiplying them. So think of this
Okay,
like
okay.
x. 2x plus 2x is 4x, yeah?
Oh,
So this would
okay,
be.
okay.
So now we have this equation, and as sophisticated as our trig skills are, we can't solve that because I have more than one thing. If it was just sine x, I could solve that, but we have something more complicated. So if you have an equation that you can't solve using algebra, you need to use a calculator. But the way we'll use a calculator is first set the whole equation equal to 0. Write that note down. We need to set the equation equal to 0. So I'm going to minus 4 over pi on both sides. Here's my new equation. 4 sine x cosine x minus 4 over pi equals 0. Everybody okay? Now, this is how we'll use our calculator very cleverly. This left-hand side, I am going to call this, let's just give it a name. Let's call it g of x. Okay, we're going to say that that is a function. And if I'm setting it equal to 0, that means on a graph, I am going to look for the x-intercepts or the zeros or the roots. This is your chance right now to say, Ms. Name, repeat. Ms. Name, I didn't understand that. I'm not going to scold you. I'm not going to shame you. So I got this function that I can't solve by hand. In order to solve it, we need a calculator. So what we're going to do is graph the function, but I need to look for the zeros or the x-intercepts. And so to do that, I need to make sure it's set equal to 0. So I move the 4 pi to the other side. And now let's go to Desmos. Okay, pull up Desmos on your computer. And I'll do it with you. Just go ahead. Wait, that's not Desmos. Okay, let's go to desmos.com. And can somebody read to me the question that we just had? It was like 4 sine x or something.
Sine cosine x.
4
Sine x.
sine. How am I going to type sine? Maybe like this. Sine x. Okay, cool. And then cosine x minus
4 over pi.
4 divided by pi. Okay. What's wrong? It says that there's an error. Oh, it's because I put y, and what I really need to do is we called it g of x, right? So let's go call it g of x. Because it needs, I think this is the problem. We'll see if it's fixed. It needs like an X and Y. No, it's not fixed. What's the issue? Use parentheses around the argument of sine. Okay, so I need to go sine parentheses X. Oh my gosh. Have you guys gotten a graph yet yourselves? Don't wait for me to do it. Do it yourself. You will be doing this on your homework. Okay, did you get a graph that looks like this? Yes, no? So this is our graph, g of x. We set it equal to 0, so we're going to look for the solution. Now, careful. There's so many solutions. On what interval are we focused? What interval did
Over
they?
2 and power over 4.
Pi
Or
over
pi over
2
4.
to pi over 4. Okay, so we only going to focus pi over 2 to pi over 4. Go to the second guy. Let's figure out what pi over 2 is. Watch what I'm doing. Pi over 2. It tells me right here, it's 1.57. So I'm going to start looking at from 1.57. And then this one will type pi over 4. Okay, do you see what I'm doing? So it's pi over 4 to pi over 2, right? Okay. So the lower limit's 0.7. So now I'm going to hit each of these. The first guy is too low, so I don't want to see it. The next guy is 1.26. Is that in the interval of interest?
Yeah.
Yeah.
1.26 is between 0.7 and 1.5. And then 1.5 actually it ends right there, right next to it. I can see 1.5. So this guy way over here, 3.47, that's outside the interval. Do not include that in your answer. What's
Miss?
our only answer?
Miss, I have a question.
Okay, just one second. Let me write down the answer. So our answer to this, the value of x that satisfies this equation was 226?
Yeah.
And there we go. And in general in calculus, just so you know, you need 4 decimals. So I think this one only provided us 3. So we'll leave it at that. If there was a 4th, you're always going to give me making it 4 decimal spots. Okay. Ask
Can
me.
you go back to Desmos?
Sure. Go for
Okay,
it.
here's my question. Aren't the roots the decimals in the aren't the roots 0.78 and 1.57? That's what I'm
No.
confused on.
No, the roots are pi over 4 and pi over 2. It's telling me on the interval between pi over 4 and pi over 2, only give me numbers that fall between that. So on Desmos, I typed in pi over 4. Look at this. I just typed it in to see what it is. It's telling me that this guy
find the root.
starts. I wish I could draw on the screen, but I can't. Here, let's see.
Oh, I think I get it. Wait, Miss, can you click the point?
This is your lower point, 0.7.
Yeah,
and the
yeah,
interval
and then
1.5.
1.5.
Tell me the
So the root
answer.
that's right there.
That's our root.
Oh, and that's
Yeah.
1.226. Or
Yeah, and I got that by clicking on the graph right there.
oh, okay, never mind. I was confused. Okay, that makes sense.
Your answer is not these. These are just telling you where to look. Your answer is the solution to the equation. Since we had to use a calculator for this equation, I moved the 4 over pi so I could set the whole thing equal to 0 and then look for the roots. That's it.
Got it.
Okay, we're going to do another graphing problem. Write this down. So that was your reminder of MVT, mean value theorem, m sec equals m tan. That was like a complicated MVT problem. Number 2 says consider f prime of x equals x e to the cosine x minus x. And this is one of those like f prime graph problems where we say, where is it increasing? Where is it decreasing? Where is it concave up, concave down, relative max? But in the past, haven't I always given you the graph? Yes.
Yeah.
This time you are creating the graph. So we're going to go ahead. Everybody do it with me, unless you just can't. And we're going to type this into Desmos. So x e to the cosine x minus x. Let's go and do that. X e And remember, you have to start with like f of x equals or something like that. Now, was this the f graph or the f prime graph? The original or the derivative?
Derivative.
Derivative. But Desmos will not let you type f prime. It's going to get confused. So we're going to type f of x, but we know mentally that this is actually the derivative graph. So we're typing f of x, but we know it's actually the f prime graph. And was it x e to the cosine x?
Yes. Minus x.
Okay, let's type that in, x e to the power. So use this a to the b button to get the power. And then let's type cosine x. And what comes after that?
Minus x.
Use the right arrow here to come down on the right, minus x. Tell me if I got that right. X e to the cosine x minus x. Your graph should look
Yeah.
like that. Okay, now the question says, consider the first positive interval. Okay, so make a note, considering positive values only. I'll tell you what that means. So if it says considering positive values only, it means that we're not going to look for negative x values. They're kind of giving you an interval. We will not be looking at the left-hand side. We're only looking for positive x values on the right. So you could be above, it could be below, but it has to be to the right, okay, positive x values. Now it says, where is the first interval where f of x is decreasing? Okay, write down f of x decreasing. So this is where your formulas come in. There's going to be two types of people today. The people that will need to look at their formula sheet for every problem, and they will be going very slow. And it's fine. You need to do that. You need to do that right now. But on your test, you won't have time to be looking. You need to know. And then there's the other people who have come prepared and know the work. So I'm going to ask those people, f of x is decreasing. What does that mean about f prime?
Less than 0.
It's less than 0. I love Michael. He's always prepared now. F prime of x is less than 0. So remember, this is the f prime of x graph. Where is it less than 0, meaning below the axis?
Below the x-axis, right?
So correct, below the x-axis. So would that be from pi over 2 until, I'm hitting all the relevant numbers. Where is this guy below the x-axis? From pi over 2 until?
3 pi over
3 pi over 2.
Pi over 2, and that's our answer. So we'll write on pi over 2 to 3 pi over 2. It'll say explain, and you've already done the explaining right there. Okay, I want to give you right now 30 seconds to copy this graph, and I'm going to highlight all the important points. So actually copy this graph down so we don't have to keep going back and forth. So draw the 0, 0. Do a max here at the 0.75. We don't actually need the y values, okay, because we always use the x values. Copy down the pi over 2 there. We have a min here at 3.57. And then end at 3 pi over 2, and then just draw the line going up. We don't care what's going on after that. Let me put them back. 0.75 pi over 2, 3.57, and 3 pi over 2. And I'm going to take a screenshot. Okay. So you should be drawing your graph somewhere here. On your homework, I'll say draw the graph, and you will do it on Desmos and copy. When I say the important points, I mean these ones: maxes, mins, and then intercepts. Okay. So some of you might be wondering, why didn't I keep looking for the next place where the graph went below the axis? Why did I stop with that? Why didn't I just keep looking? Because the graph does go below the axis more and more.
It asks for the first positive interval.
Thank you. It says right here, find the first positive interval. So I'm only going to do the first one that I see of x, the first positive interval of x. Okay, let's do the next one, B. Find the first interval of x where f of x, write this down, is concave down. F of x is concave down. So if f of x is concave down, what's that mean about f prime of x? Don't give me the double prime derivative, double prime definition. We're dealing with the f prime of x graph.
Decreasing.
If I'm concave down,
Decreasing.
then f prime of x is decreasing. Was that Haley or Kaylee?
Kaylee.
Good job, Kaylee. Kaylee studied this. She memorized them on the first day. F prime of x is decreasing. This is the f prime of x graph. So have a look. Where is it decreasing?
0.755 and to 3.57.
3.57. Nice. 0.755 to 3.57. You should have this drawn on your paper. Okay, let's do C. So this is it. When we talk about the calculator problems, they're stupidly easy. You just have to draw them yourself. Let's look at C. It says, find the first interval where f of x is concave up and increasing. So I have two conditions now, two things to look for. First, it says f is concave up. So what's that tell me about f prime of x? If it's concave up,
Increasing.
it's gonna be increasing. And then if f of x is increasing, what's that tell me about f prime of x?
Has to be above the graph, above the x-axis.
0. F prime of x must be greater than 0. So now we are going to look for the places that satisfy both conditions. So this graph needs to be both above the axis and increasing. Tell me where it's true. It's above the axis and it's increasing. And we only want the first interval.
0 to 0.75.
Yep. You can say it with confidence, Kaylee. From 0 to 0.755. Not only is the graph above the axis, it's also increasing, meaning that f is concave up and increasing. So on 0 to 0.755. Nice. Okay, let's give D, let's do E. Find, write down first relative min. First relative min. So if f has a relative minimum, what does that tell us about f prime, the slopes?
Changes from
Changes from
negative to positive?
From negative to positive. Are you sure? Because you sound a little worried.
Yes.
Yes, you are. The slope is negative, then the slope is positive, meaning that we went down, we went up, we have a relative min. So where is f prime? This is f prime. We're changing from negative, meaning below the axis, to positive, above the axis.
Pi over 2.
At pi over 2,
pi over
we're changing
2.
from positive to negative, right? So it's not pi over 2. It is
3 pi over 2.
3 pi over 2. Sweet. Cool. So this is like a review, but you're also learning something new here. Okay, let's do F. Find the first two inflection points. Write down first two IP inflection points. Okay, Kaylee, be quiet. Who else? Michael, be quiet. Let's see if the rest of the class can do this. If I have an inflection point on F, what does that mean about F prime?
Equals 0 or switches. Sign.
Isn't it
It's
switches
a
from
critical
negative?
point. It's a critical point, Naya. Bridget?
Inflection changes from negative to positive and positive to negative. Something along
No.
those lines.
No.
It switches from increasing to decreasing or decreasing to
Thank
increasing.
you.
There you
F
go.
prime switches from decreasing to increasing. This isn't something that you're gonna like figure out because inflection points working on the double derivative. It's where f double prime equals 0 and switches signs. But you memorize it also means f prime switches from increasing to decreasing, or the other way around, decreasing to increasing. So let's first focus on where does f prime switch from increasing to decreasing? Look at f prime, where is it increasing and then decreasing? What point does that happen?
0.755.
0.755, it changes from increasing to decreasing. And where's the other? So that's our first inflection point. They want the second inflection point also.
At 3.57
What happens at 3.57?
goes from decreasing to increasing.
Yes, so at x equals 3.57. And our reasoning is f prime switches increasing, decreasing, or decreasing to increasing. Okay, I'm letting you know right now that you're taking a quiz on Tuesday, right? Tuesday's the next time I see you guys. And it's going to be a quiz on these definitions, okay? So we won't be able to move forward comfortably with the material if we're shaky. And so that's why we're going to take a quiz just on the definitions. And I'll give you like one graph like this on the quiz. Okay, definitions and one single graph. That's it. I promise it won't be more complicated. Okay, let's look at number 3. So careful. What do you notice about the graph they gave us in number 3? Did they give us the original or the derivative?
Original.
The original, but we will always use the derivative. We will always use the derivative. So we're going to type this into Desmos as it is. So go with me, right? 1/2 sine e to the x minus 3x. Can somebody read it to me one more time? Was it 1/2? I need help.
1/2 sine e to the x.
Okay, 1/2 right arrow parentheses sine of e, hit the AB button to the x, and then close parentheses. No, minus 3x. Okay, the right arrow to come down, then minus 3x. Jerry, are you doing this on your computer? Isaiah, are you doing this on your computer?
Yeah.
Did you get this graph?
Yup.
Okay, next, that's the original. We need the derivative. So in your next guy, you're gonna write f prime, use the apostrophe. Okay, where's the apostrophe? Dang it. If you see one, let me know. I think it's that one right there. Okay, so I have to hit shift and then I hit the comma button and parentheses x. No, go back. X. All right, let us now. You should see a graph like mine. It's crazy, right? Looks like mine. We're going to now suppress the original graph by hitting the color on the left side, this circle. So now I only have to look at the derivative. We're going to zoom in. And what we're going to do is copy this down on your paper, all the relevant points. So I'm highlighting them. So 1.231 is our first min. Go ahead and draw that. And then 1.67 is our first 0. We have a max at 1.862. That's the x value. Notice I'm only giving you x values. And then we have another 0 at 2.007. And let's just work with those because it seems like, you know, that's enough to get our first of whatever they're going to ask for. So copy that down. Once again, we have, gosh, where's it not showing up? Okay, come on. Stupid thing. I don't know, it's not working for me, you guys. Anyway, the point is we're not going to actually do this problem, but I just want to show you if they give you the original, write this down. Graph f of x in box 1, and then you're going to type f prime of x in box 2. Then we're going to hide the first box so that we're only operating on the derivative and we can then answer all the questions, just like we did in the last problem. I'll leave it at that. Any questions? Okay, you'll have one F prime graph for your homework and you'll have one F graph for your homework. Make sure you're not mistakenly using the original function. Always use the derivative. Okay, we move on now. Now we move on. So I'm going to give you a chance to copy this and the units, okay? Actually, no, you can just copy that and copy this interval. This is our word problem. So for the next 15 minutes, when's your next class start?
10:35.
10:35.
All right, for the next 10 minutes, okay, I need your absolute undivided attention. Copy what I underlined. Now we're gonna read the problem. I want you to process it with me. It says, it's snowing and a homeowner wields a snowblower to remove snow off the sidewalk. He's got a snowblower, he's getting it off the sidewalk. The amount of snow on the sidewalk is changing at a rate modeled by this function, measured in pounds per minute. So let's make sure we understand what's going on. He's getting snow off the sidewalk, and the rate at which the snow on the sidewalk is changing is modeled by this function. So the first question is, think before you answer. Is this the original function or is this the derivative? Nobody speak. Think. Look at the question. S of t, is this the original function or is this the derivative? And if you're clever, you'll tell me 2 reasons why. You'll give me 2 pieces of supporting evidence from the question that tell you whether it's the original or it's the derivative. Think first. Is S of t the original function or the derivative? Read it very carefully. And if you're clever, you're going to give me 2, not 1, but 2 reasons why you can support your answer. I'm accepting responses, suggestions.
I think I have it, Miss.
Go.
It's not the original function because in A it says state the original function.
Okay,
And
all right. But not from A, from the original question. Give me 2 reasons. So you're saying this is the derivative.
Yeah.
Okay, you're right. This is the derivative. Now, how did you know? How do you know?
Well, the second piece came from that question. It says changing at a rate, which I assume is like slope.
Thank you. Changing at a rate of. We used that language last time to describe derivatives. At a rate. Rate means slope. So this, everybody write changing at a rate, right, equals derivative. Okay, which other person can give me 1 more reason why I know this is the derivative from the original question? Psst, look at the units. Psst, look at the units.
Pounds per minute.
Pounds per minute. Does that suggest a y over x? Pounds per minute. That's a rate of change. So that's another reason. Write down pounds per minute. Also indicates a derivative. So what we need to do first is separate the original function from the given function. So here's what we will always do. First, we'll write the original function. We'll always label it a of t. So notice that they gave us the rate at which the amount of snow on the sidewalk is changing. So what's the original function describing? The amount of snow on the sidewalk. The original function tells us the amount of snow. I'm just getting it from the question. Nothing clever is happening. It says the amount of snow on the sidewalk is changing at a rate. So now they're giving me the derivative. But the original function is the amount of snow on the sidewalk, period. Measured in what, guys? What's the units? Look at the question. What would the original function be measured in? Pounds. The amount of snow on the sidewalk would be measured in pounds. So now we're going to talk about the function they gave us. Write this down. Didn't they give us the derivative? Yes?
Yeah.
Write something, see if this makes sense. The derivative, the rate of change, the slope of a of t is what they gave us, S of t. Yes, does that make sense? Everybody on board?
Yes.
Now we need to explain what that is. This is not the amount of snow, but the rate, write this down, the rate of change of, you can abbreviate amount to AMT, of snow. Not just of snow, but of snow on the sidewalk. Be very specific. And now we're going to be measuring in pounds per minute. Ta-da. Okay. Notice that your y variable up here, this is your y variable, is in pounds. Your x variable is t in minutes. So then the derivative would make sense to be pounds per minute, y over x, like we did last time. Okay, so we answered A. What I'm gonna do now is graph this thing. We're gonna graph this thing. So everybody go into Desmos, write S of t equals t over 3. So Desmos is really sensitive. It doesn't like t values, so you're gonna write it as S of x. Okay, I'm teaching you how to use the calculator. So we're gonna write S of x. Somebody tell me what to write next. Equals x over 3 times what? Use the right arrow, open parentheses. Sine of, you guys are super helpful, sine of 3x squared over 7. Come on, I'm telling you I need help. Equals sine of,
Sine of 3x squared over 7.
thank you. Whoops. A to the b squared over 7?
Yep.
Over 7. Okay, cool. So that's my S of x or my S of t. Go ahead and copy these numbers. It says to focus on the interval 0 to, it says it right here, 0 to 5. So we're only going to copy the numbers between 0 and 5. Okay, I wrote them down. Quickly copy 2.7, 2.707, 3.352. We have then a 0 at 3.829. We have a max at 4.298. And then we have a 0 at 4.689. This last min is outside of the interval because it's 5.076 and we're only looking to number 5. So you would copy just those ones. Okay, make sure you have them all on your paper. I think I missed one in my screenshot. Which is fine. Okay. Make sure you have it done. And you, on your homework, I'm expecting you to draw if I ask you to. Okay, so B says, how fast, write this down, fast is the amount of snow changing at t equals 3. How fast is the amount of snow changing at t equals 3? So pay really close attention. They could ask me two things. What is the amount of snow at time 3? Or what is the rate of change of the amount of snow at time 3? Look at the question. Are we going to plug this into A or into A prime? Are they asking me about the amount or the rate of change of the amount? And how do you know?
In the second one?
I'm going to plug it into the derivative. How did you know I need the derivative? What word stood out?
Changing.
Changing and how fast. When we're talking about speed or motion or things like that, we're talking about the derivative. So we're going to find A prime of 3. So write this down. We need A prime of 3, which we need to connect, which is S of 3, which is what they gave us. So guys, this is so easy. We just need to find S of 3, meaning we plug it into our calculator. So go back to Desmos. In the second box, you're going to write S parentheses 3, and it's going to tell you the answer. Somebody read me the answer to 4 decimal places. Negative. So go ahead and write it in and tell me what you're getting. Negative what? I hope you guys are doing this with me. 0 point, I need 4 decimal places.
6560.
6560. Okay, so now we're going to interpret this. By the way, what are the units on this? Psst, we're in the derivative. Look at S of 3. We wrote it up here. This is why it's super helpful. What's
Pounds
our
per
unit?
minute.
Pounds per minute. And now we're going to write a sentence. So we'll say indicates that. Who can help me? Indicates that what? We'll start with from left to right as a reminder, starting from here, starting with the x value. So at time 3, then we say the y value next. What's the y value? Psst, this is the y value. Label it on your paper if you like. That's the y value. The amount of snow on the sidewalk is what? Okay, which person studied is what?
I have a question, Miss. Would it be like
Okay,
decreasing?
would it be decreasing?
Yeah.
I love you, Haley. I love you so much. Yes, it's decreasing. Notice she didn't say changing at a rate of, but we know the sign is negative, the slope negative, so it's decreasing at a rate of. Very good. At a rate, don't forget to say at a rate of 0.6560 pounds per minute. Ta-da! We are done. Okay, so I'm letting you know that in office hours, we're going to do we're going to finish the problem C, D, E, F, G in office hours. You must either attend or watch office hours. Must attend or watch because this is so, so important and you will see one problem like this on your homework. Okay, you can probably figure out C and D on your own, but E, F, and G, I want to be there with you to do this problem. All right, guys, have a great day. Go to your class. I love you so much. Bye.
Bye.
Bye.